Well, let's talk about some of the steps that are involved in machine learning, typically from beginning to end. So we're going to take a big picture overview here of where we might start to where we might end in a machine learning problem. And then later in the course, we're only going to look at one or two of the individual steps in this overall process. So to begin with, we have to have some data. If we're going to analyze the data using a computer, we have to collect the data to begin with that we're going to use. As I go through these steps, I'm going to keep an example of face recognition. We're going to have some pictures of faces. So we might get those by using a camera and collecting images, or maybe we can draw from a database of existing images. Next, we're going to want to pre-process the data that we've collected. And this might be doing something like making all the images a common size, perhaps centering the faces, rejecting poor quality images. Maybe the exposure is not right or the image is blurry. So we don't want those in our example data set because they're going to bias our answers. And this pre-processing step is very time consuming, and it's also very important. To get really good results, people spend a lot of time pre-processing their data and make sure that it's a high quality data set. This can be the most time-consuming part of solving a machine learning problem. So once we have data, we do something that's called feature extraction. And this amounts to deciding what attributes of the data are relevant. So if I have a picture, the RGB values for all the pixels in this image is probably a little bit of overkill if I'm interested in recognizing faces. In fact, it may actually hinder me. What I'm going to do is identify some key features. For example, I might choose the landmarks that I've shown here in red, the corners of the eyes, corners of the lips, landmarks on the nose, chin, and so on, ears, and then measure the positions of those landmarks and collect those measurements into a vector. Once I've defined what my features are going to be, I may also want to collect some training data. Now the training data, if I have access to it, not all problems have training data, we'll talk more about that later. If I can obtain training data, what that means is that I have some known examples. I collect some images, in this case, if we're doing image recognition, where I know the identities. So I can train my algorithm to recognize that this is me, this is Gauss, and this is Dave. I have all these images with the correct answers attached to them, and I use that correct information to train the algorithm to discriminate between these different individuals. So once we extract the features from the data that we've collected, after we've cleaned it up, we're going to identify or collect a set of training data that will allow us to learn from the data what the correct answers are. Now, machine learning is based on use of models. And a model is something that captures the salient or the important aspects of the data with respect to the type of decision we want to make. A model might be that we believe a series of data points, perhaps the stock market index, should be relatively smooth. We would apply a model to take these noisy measurements and smooth them and then allow that to make a prediction. In our face recognition problem, we may model the identity of the person as being represented by the differences in these landmarks relative to the mean across all people. So it's not the absolute position that matters so much, perhaps, as the differences. So that could be a model that we would assume when we are trying to do face recognition. Or if we're trying to predict movie ratings, one model would be to say that a person's ratings are a weighted combination of nominal taste profiles. And you could imagine that you have people who generally like science fiction, you have people that like romance novels, you have people that like action films. If we take any given person, they might like or dislike some mixture of those, and so we could think about their preferences based on a weighted combination of these other categories. So somebody might be 80% action, 10% romance, and 50% sci-fi. So all of machine learning is based on the use of models. The machine needs to operate on a mathematical model in order to perform the sorts of inferences and predictions that we like. one of my favorite quotes by the famous statistician George Box, who was a professor at the University of Wisconsin. All models are wrong, but some are useful. And so the value of a model is not if it is perfect, but if it allows us to make useful predictions about the data. So one example is Newtonian physics. Newton postulated these laws of gravity that actually allowed people to quite accurately predict the orbits of planets in the solar system. Now we know that Einstein came along and developed a theory of gravity that proved that Newton's was incomplete. It was wrong. But Newton's theory of gravity was still very useful because it allows us to make predictions under many, many scenarios. So the true test of a model is not whether a model is perfect, but whether the model allows you to get useful results. And usually when we apply the model, that's the stage at which we're getting the actual desired outcome of our machine learning problem. So applying a model is the last step in the machine learning process. That is what is usually going to give us the outcome that we seek. Now I mentioned that we can't always collect training data. This brings up two different categories of machine learning problems. In a supervised learning problem, we have training data. In other words, we have example data where we know the truth or the correct outcomes. And we can use that data to train our models. So we build our model based on the correct information we have associated with this training data. And then when we try to make a decision, we're going to apply this model that we trained to the new data. For example, I might try to differentiate images of dogs versus cats in a classification problem. My training data would be examples where I knew the labels that this image is a cat or this image is a dog. And then I'd train my classifier to differentiate between dogs and cats on the basis of that training data. And then if I have some candidate image which I don't know whether it's a dog or a cat, I'm going to apply my model to that new data and I'm going to let it tell me whether it's a dog or cat. Now this is called supervised learning because we have these examples that are used to train our process. Now the other category of problems is unsupervised learning. And in this case, you don't have data where the truth is known or where you have examples of the correct outcomes. And in these types of problems, it's common to use models to differentiate general characteristics of the data. So for example, you might collect some data and believe that it should be clustered in two groups. So if I go back to my image or my face recognition example, I might say that different pictures of me should be more similar than a picture of someone else and a picture of me. Okay, so I might say there should be some clusters, and if I can cluster the data, then I can identify all of the images that correspond to the same person. So I may not know this image is of Barry, this image is of Gauss, but by finding the clusters in the data, I can maybe infer the cases that are similar. So in this little sketch, I've drawn some two-dimensional data where maybe my features were two measurements, and I have one set of features that tends to form a cluster in the upper right, and then another set of measurements where there's a cluster of data in the lower right center, and we could try to learn the boundary between these two clusters so that then if I have another observation, I can decide in which cluster does that observation belong. So these are high-level perspectives on machine learning problems and become a lot more concrete as we look into the details of specific methods and specific examples of how to apply these general principles to machine learning. Now the case that we're going to consider most of all in this course, now the step that we're going to focus on in this course concerns the model step and applying the model. We're not going to worry too much about data acquisition or data cleaning and pre-processing. We're going to focus almost entirely on how we work with models, how we train models, and apply them to data.